Hello viewers, welcome back to another session with me. You are welcome to Master Builders Online Academy. If you are new in this channel, do consider subscribing to our channel and ensure you turn on the post notification bell for more exciting videos, guys. Now, welcome. In this lesson, I will be holding you by hand and showing you how to solve force system or concurrent force system. I know you like that. Maybe it has been an issue to you. Worry no more. I am here to hold you by the hand and teach you what you need to know in just one problem that I will teach you in this lesson. You can solve more than 1 million problems on your own because what I will teach you is enough to cover for other problems I will not attend to. Please don't doubt. Just relax. Don't relax. I will do that while you sit watching me. Okay, so one of the things I will require from you is that you should avoid every unnecessary distractions. This will not do you any good. All right. Then secondly, do ensure that you do not skip any part of this video. This is because every part of this video is encrypted with principles that works. So if you skip any part of this video, you may skip an important part that would have given you the concept about solving this problem. So please do not skip any part of this video. And if after watching this video at the first time and you have questions to ask, please you can slide to the comment section and make your questions known to us. We are very good at answering questions. This is what we do. We'll do that for you. And if for instance you watch the video and you need to get some more concepts, guys, you have the opportunity to replay the video over and over again. And this is one of the reasons why lessons are coming in video format. So you can play and play and replay till it sinks into your mental capacity. The capacity is there. Now let's continue with what we have on the board. Now, on the board, we have problem number 10. Remember, we are solving series of problems in engineering techniques with some different subtopics. All right. So now this is what we have. We are asked to determine the resultant. Sometimes you'll be asked to determine the resultant and the direction. Whichever case, you will always have the same result. Okay. You don't need to bother yourself about that. You have the same results. Now we have this sort this way. Okay. Now, what do you do in solving this problem? In solving this problem is something very, very simple that you can handle without actually stressing yourself to some extent. Now, so to solve these problems, what you need to do is that you need to always find the resultant. Either you are asked to find the resultant or you are asked to find both the resultant and the direction. Most often the time, whether or not you are asked to find the direction, once you obtain the resultant, you are expected to know or calculate for the direction of the resultant. Why? Because all these active forces, these concurrent forces that are acting at a point, they all have their respective angles to which they act. So the same way, the force that you will calculate to represent these four forces, which is the resultant force, is a force that can actually represent these four forces, should actually have a direction. So whether you are asked to calculate the direction or not, there is always a need to calculate for the direction. So now, to calculate the resultant of any concurrent forces acting at a point, you first of all resolve this whole system to x component and y component. Resolve it to x direction, resolve the component to y direction. So you get two forces, one in x, the other in y. From what you have, you can now use Pythagoras theorem to analyze. So let me quickly give you the model for solving resultant and the angle. So first is that the resultant of any concurrent forces R is given as the square root of sum of fx squared plus sum of fy all squared. Why the direction? Direction theta depends on alpha. Now to find this alpha, we have that alpha is equal to tan inverse of sum of fy over sum of fx. Don't worry, I will explain this aspect of theta. Now, one of the things that you need to understand is that the direction of the resultant depends on the quadrant from which the resultant comes out from. Remember that we have the first quadrant, we have the second quadrant, we have the third quadrant, then we have the fourth quadrant. So if the resultant comes out in the first quadrant, the direction will be different from when it comes out in the second quadrant. And the direction will be different from when it comes out from the third quadrant. And it will equally be different from when it comes out from the fourth quadrant. So this I will teach you as we progress in this class. So when it comes out from the first quadrant, listen carefully. So let's say for instance, this is the first quadrant. Okay, when it comes out from the first quadrant, this is the angle. This is theta. And theta is equal to alpha. Alright, so what you calculate for first is alpha. The value of sum of fx and sum of fy you have, you use it to calculate for alpha. Whatever you have as your alpha can be used to calculate for the actual direction. So now remember that this is first quadrant, second quadrant, third quadrant, and this is fourth quadrant. Okay, please just follow me so you get it very clearly. So this is 0 degrees, 90 degrees, 180 degrees, 270 degrees, then back to 360 degrees. So your journey is in this direction, anti-clockwise direction. This is how you move. So when it is on the first quadrant, if you want to find the resultant, this is what you do. You take it from here when it is on the first quadrant. So your direction becomes from 0 to where you meet the resultant. So if here is alpha that you calculated, theta here is equal to alpha. That is the direction. But if it falls out, if the resultant now falls out from here, this becomes the resultant. The alpha you calculate is a quadrilateral angle. Remember, alpha is a quadrilateral angle, so it's an angle you find within the quadrant. Now this is what you have. So alpha must lie between the resultant force and x-axis. Don't forget, alpha must lie with the resultant force and the horizontal axis. So you see that this is where alpha is. So to get the direction of the resultant, it will be this, which is what theta. So from here, if I want to find theta, theta is equal to 180 minus alpha. So whenever your resultant falls out from the second quadrant, this is how you obtain the resultant direction. Now what happens if it now falls from the third quadrant? Remember, if this is my resultant and I want to create my angle, the angle will be what? Alpha will be between the resultant and the horizontal axis. And in this case, the direction will equally start from here to where it meets the line. So this becomes the direction of the resultant, from 0 to where you meet the resultant in a clockwise, anti-clockwise direction, right? So this is in the third quadrant. Now, so when the resultant is in the third quadrant, the direction of the resultant becomes 180 plus alpha, because from here to here is 90, from here to here is another 90, which is 180. Then plus this little angle here is what will give you this rotation. Are you there? That's what will give you this curve. The sum of this plus 90 plus 90. So this is how you get it. But when it comes out from the fourth quadrant, that is your resultant. Now this is how you get your alpha, because alpha must lie between the resultant and s-axis. So in this case, after obtaining the value of alpha, remember that the direction of the resultant will start from 0 degrees and move in an anti-clockwise direction to where it meets the resultant. That means this is my theta. And remember that when the sum of two angles gives you a complete cycle, this is what we refer to as what? Reflex angle. Reflex angle, when the sum of two angles gives you a complete cycle. It shows that to find alpha, theta here, theta would have become 360 degrees minus alpha. Just understand that this is for first quadrant, second quadrant, third quadrant, and fourth quadrant. So when your resultant falls out from the first quadrant, theta is equal to the alpha calculated, the angle calculated. But when it falls out from the second quadrant, theta becomes 180 minus angle calculated, which is alpha. Then when it falls out from the third quadrant, angle becomes, the direction of the resultant becomes 180 plus alpha. But when it comes out from the fourth quadrant, it becomes 360 minus this. So any question you are given at all, this question that we have like this now, we fall out to be any of these four categories, because we have four quadrants: first, second, third, and fourth, right? So because we have four, we definitely have four equations. So it depends on wherever the resultant falls out from. This is what determines the direction of the resultant force. I hope you have gained a lot of values already without solving. Okay, now let's dive into solving this problem. Now, to understand that there are two ways by which this problem is solved. Two methods. Number one is the direct analytical method. The number two is the tabulated method, which is the tabular method. So you either use table to resolve concurrent forces or you use direct analytical method. So very shortly, I will make use of the two methods without wasting much of your time. But one of the things is that when you are using the direct method, you need to understand the position of the angles so that you know that when you are resolving along x, sometimes you have f cos theta, right? And when you are resolving along y, you have f sin theta. But in most cases, it's not always like this. Sometimes you see that when you are resolving along x, this is x, this is y. You see that when you are resolving along x, you now have f sin theta. And in another case, when you are resolving along y, you now have f cos theta. This is what you have. So these are the two cases. When should I use this? You make use of this when the angle lies with s axis. So anytime the angle lies with s axis, what I mean now that the angle between the given force and s axis. Okay, so when the angle you are given is between the force and s axis, you use cos theta when resolving along x, and use sin theta when resolving along y. But when you now find out that the given angle between the force, in this case, this is what I'm trying to explain now. If this is what I have, this is f, I will use this method. This is what I will use because the angle between the force, the angle of the force is line between the force and s axis. So, but if I have it this way, you find out that theta is here and this is f. So, because the angle is now line with y will now carry cos theta. So, when I'm resolving along y, I have cos theta, but when I'm resolving along x, I have sin theta. So, the one that the angle lies with is the one that carries cos theta. Cosine theta, whichever case you pull out. Alright? So the one that the angle lies with. So if the angle lies with x axis will be cos theta. If the angle lies with y axis, s axis will be what? Cos theta. This is the conditions to which you apply this aspect. Having known this, then the next is what? Seeking to understand direction. In understanding directions, one of the things is that if this is your axis, remember that this is plus y plus x minus y minus x. So if I am resolving forces along s axis as stated, all I will do is to draw a reference line in y direction. I'm resolving along x, so I will draw a line in y direction as my reference line. I'm calculating for x, but y will become my reference line. So now what I will do is that this is the left end, this is the right end. Any force heading to the left is negative. Any force heading to the right is positive. So when we look at this now, this is the reference line. To the left end here is negative of x. To the right end is positive of x. So when you are resolving forces, you need to know whether the force you are resolving is facing the right hand side or is facing the left hand side. So when it is facing the right, you resolve it to be positive, but when it is facing the left, you resolve it to be negative. You must pay attention to this sign, otherwise you will have issues in solving these problems. Again, if when I'm resolving along y, I now define that I'm resolving this system along y axis. Listen carefully, it's just something you can understand with bits of steps. Okay. Now I will now make x as the reference line. Look at it. I'm calculating for y. So on top of this line, this is top, this is bottom, this is x as I just created. Okay. Now anything on top when I'm resolving along y, heading upward this way, must be positive, and anyone heading downward must be negative. This which is respect to this sign. On top here is positive, beneath here is negative. So understand that when you are resolving forces, you need to identify, listen carefully, you need to identify where the angle lies. Is the angle lying between the force and s axis or between the force and y axis? That explains the condition of this. One. Then number two, you need to identify again is the direction of the forces. So now when you are resolving along s, is the force heading to the right or heading to the left? If it is heading to the right, positive. If it is heading to the left, negative. Now, when you are resolving again along with y components, guys. Now, you now need to identify if the direction of the force is upward or is downward. Clear? So if it is upward, it's positive. If it is downward, it's negative. If you understand this concept, you will not have issues with resolving concurrent forces or force system. Okay, so these are the major two keys you must identify: where the angle lies and the direction of the forces. If you understand this analytical aspect will not be a problem. But for the other case, which is the tabular method, that one does not matter. Whether you consider the direction, it doesn't matter. You only calculate for included angle. That's what matters. Okay. For now, let's use this analytical method. Having explained the direction of the forces and the angle the forces made, either with X or with Y. I hope at this level I deserve a hand of applause. Please follow me. That's why I mentioned that you shouldn't skip any part of this video, because every part of this video is encrypted with principles that will make you wise. The wise masters, right? It will make you wise. Now, let's get. So the first thing is to define that you are resolving these forces along X axis. Resolving the forces along X axis. Now we are resolving these forces along X axis. You will start for the first force on the first quadrant. This is the first quadrant. Don't forget second. So the first force here is 150. Is that correct? Now remember, now that we are resolving along X, what do? You create a Y line. So all the forces in this end will be positive. All the forces in this end will be negative. So let's quickly identify. Now that we are resolving along X, now this is Y. So this and this will be positive because they are to the right hand side. While this and this will be negative because they are to the left hand side. And again, we have seen that all the angles the forces made are with respect to X axis. This one with X, this one with X, this one with X, and this other guy with X. That one is already clear. So now we have that this becomes 150 cos the angle is 30. Why are we using cos? Because the angle lies with X. So as long as the angle lies with S, it should be cos theta. Again, now that the next force is on the second quadrant, now that on the second quadrant, this force is heading to where? To the left. So it shows that this will be negative minus 200 cos 30 again. Then the next force is on the 10th quadrant and the angle lies with S. We are still using cos theta. But where is it? At the negative side. That means this will be negative 80 cos 60. Then finally we now have plus. Why? Because if this is our reference line, this one is positive to the right hand side. Then this becomes plus 180 cos the angle is 45 degrees. So sum of fx. Now you can compute these values individually. Okay, you can compute them individually, but as long as I have to sign, I'll compute it once. So when you compute everything here once, you're going to have 44.0 Newton. This is the resultant force in X direction. Now I want to get the one in Y direction. Now we have resolving this system in Y direction. Now we have stated that we are resolving this force in Y direction. Is that correct? So we'll now make X our reference line. Resolving along Y. So we make X reference line. On top is positive, beneath is negative. So when we come here, identify this force now. These two will be positive because they are on top of X. While these two will be negative because they are facing the negative side of Y. Are we there? So this is the reference line. Anyone on top is positive, anyone beneath is negative. So automatically this will have given us 150 sine 30 plus 200 sine 30, then minus 80 sine 60, then minus 180 sine 45. You are only changing the cos to sine. The angle remains the same. Only changing cos to sine. That's what we have done so far. What do we need to do? All we simply need to do here now, without wasting much of our time, guys, is just to obtain the absolute value of this resultant force in Y direction. So by the time I compute everything value here inside my calculator, I will have minus 21.6 Newton. This is what we have as the component of force in Y direction. So what do we need to do now to find the resultant? We now need to sketch these two forces so we will know the quadrant to which this resultant will come out from. Now I know that S is positive, so if you have your quadrant this way, please follow me. Plus of X, plus of Y, negative of X, negative of Y. So this is what we have. So now, since X is positive, I will be using this for X. And since Y is negative, I will be using this for Y. That means what we need now is this. X positive, Y negative, based on the values that we have here. It shows that our resultant force will come out in the fourth quadrant. You see how it works? Yeah. I deserve a hand of applause. Very simple. So what do we do? You just say, okay, sketching the resulting forces. We have this and we have this. Why the resultant comes out in between. So this guy is sum of fx, fy. This guy is sum of what? Fx. And remember, alpha that you introduce will be between the resultant and x as this. So you introduce your alpha. And you can now generate a line here to meet with the resultant, which you know that this line, what you have here is parallel to what you have here, and what you have here is parallel to what you have here. So the value of y, the value we have for y, remember that here is angle 90 perpendicular. The value for y is 21.6 Newton, while the value for x is 44.0 Newton. So we have the value. Now what do we do? When you are finding the hypotenuse when opposite and adjacent are known, you use Pythagoras theorem, and that's exactly what we have here. So automatically the resultant r now becomes the square root of what is our sum of fx? Sum of fx is 44.0 squared plus sum of y would have given us what? 21.6 all squared. So when you compute what you have here and solve, your final answer will be what? An approximate value of 49.0 Newton. This is what we have when we solve this. So this is the resultant force for this force system. Are we there? So the next thing we are quickly going to do now is to find the direction, because like I mentioned before, whether or not you are asked to find the direction, you must find it. Because all the forces that you were given, to which you used to find this, all have directions. So that means without being asked to do so, you need to know the direction of the resultant. So now the direction of the resultant, we start from 0. Remember that this 0, 90, if we start from here to where it meets the resultant. This is our theta. So for us to find theta, we need to first of all find alpha using that formula, this. Remember I mentioned that the direction of the resultant depends on alpha. Now our alpha is on the fourth quadrant. So now recall that alpha is equal to tan inverse of sum of f over sum of fx. And this becomes tan inverse of sum of fx, fy is 21.6 all over 44.0. And when you find the angle of this guy, you will have 26 degrees. So this gives us 26, an approximate value of 26 degrees. The tan inverse of 21.5 divided by this. Now remember, because you have already considered the quadrant, you don't need to consider the negative sign of this, because it has already been implemented on your sketch. So that's why you're not using minus 21 here, and even why you did not use it. Remember, even though we have used it here, when you square it, it will turn to positive. But for here, we do not need to use it because we have already considered the quadrant to which the resultant is coming out from. So there won't be need for you to apply the negative sign there. Otherwise, you have it wrong. Except you do not have this sketch. So now that we have this raw sketch, how do we now get our resultant? Remember that the resultant must start from this 0. This is 0, like I mentioned before, 0, 90, 180, 270, 360. Is that correct? So you start from 0 and move in an anti-clockwise direction. So this is our resultant. Therefore, resultant direction of the resultant force and resultant force theta is theta will now be what? Equal to, now since it comes out from the fourth quadrant, what is the formula I gave? I said this will become 360 degrees minus alpha. This gives us 360 degrees minus 26. And when you do this, the direction becomes 334 degrees. This is the direction of the resultant force. This is the direction. So we have obtained the resultant force, and we have equally obtained the direction of the resultant force, which is very, very simple. Guys, Hope you are getting massive values from this channel, free of charge. Now, even now that we have obtained this, like I mentioned, there are two ways to have this done. So let me quickly test run the second method very quickly for you. Now, how do you use the second method? Method 2. Let me just summarize it here. Method 2, which is what? The tabular method. Okay? When you are using table, you take your first. So the first column is the first, which is in Newton. You know that. Angle in degrees, then component of x, component of y. Now the next thing you do is you come here and check how many forces do we have. Starting from the first quadrant. The first force is 150. So you put in 150 here. Already the Newton is already covered here. You rule this. The next force is 200. You rule this. The next force is 80. You rule this. The last force is 180. You rule this. So this one becomes forces in S direction. Forces in S direction. So Fx. Forces in S direction, which will give you what? F cos theta. Forces in Y direction. F sine theta. This is the condition. So in this case, like I mentioned before, you don't need to consider the direction, but the angle matters. So how do you now get these angles? So what you do is, like I mentioned before, let me remove these guys. Like I mentioned before, this is 0 degrees. So your journey for all the angles must begin from 0 degrees. So you start your journey from here to this point. What is the angle of 150 Newton from 0 degrees? From 0 degrees, that would have given us 30. That means the angle of this is 30 degrees. Okay? What would have been the angle of this one? You start again from here. From here to this point will be the angle. Now remember, from here to here plus from here to here would have given us angle on a straight line. So 30, as me here is x. Now the angle I'm looking for is x. 30 plus x must be equal to 180. Reason, angle on a straight line. So by the time I make x square formula, I will be removing 30 from 180. And if we remove 30 from 180, we will have 30. That means the angle of this force from this starting point is 150. You put in here 150. That's for that. Now we come to the third force on the third quadrant. So we equally move again. We continue our journey from here to where we meet the force. This is where we meet the force. Remember that from here to this point is already 80 degrees, 180 degrees, half a cycle. Then plus 60 would have given us this curve, right? So that means we are going to have 180 plus 60. And 180 plus 60 will give us 240 degrees. That means the angle of this force from 0 degrees from the starting point is 240 on the third quadrant. Remember, it must be more than 180. Because this is where you have 180 and it's in the third quadrant. So forces in the third quadrant are forces whose angles are more than 180. Right? So this is what we have. Then this becomes 240 degrees. Then finally for the last angle, which is we have here on the fourth quadrant. Remember, the journey will equally begin from here to where you meet the force. This is it. From this end to where we meet the force. Now this is where we meet the force, correct? Now that we have met the force at this point, remember that from here to here is what we are looking for. This is where we meet the force. Now this point is known. The sum of 45 and s will give us 360. That means all we simply need to do now is to remove 45 from 360 to get the remaining angle. So if we remove 45 from 360, we will have 315. And this becomes 315 degrees. Once you are able to get these angles accurately, this problem is half solved. So what do we need to do here? For here, what you do now is that this is the forces. These are the angles. So this becomes 150 cos 30 for x. Everything that you are using here now will be first cos the angle. First cos the angle. So 150 cos 30 would have given us 129.9. This one will have. Then 200 cos 150. First cos angle. So 200 cos 150 would have given us minus 173.2. That's right. Then 80 cos 240. 80 cos 240 would have given us. Then when we now have 180 cos 315, we have 127.3. These are the components of forces. So what do? Just pick your calculator, add all the values that are here together. When you add all these values here all together with their respective signs, this is negative, this is negative, this is positive, positive, at the end, you will have your final answer as 44.0 Newton. This becomes sum of Fx. Now the next is to find sum of Fy. And to find sum of Fy, we need to get all these forces again. So what we'll do now is force here, sine 30. Remember that the sign that you have here now. So 150 sine 30 will give you 75. That's the first thing. You can say 75.0 if you want to put it to decimal place. Then again, we have 200 sine 150. 200 sine 150 will give us 100.0. You can use your calculator to have this done. Then again, we have 80 sine 240. We have minus 69.3 Newton. Then finally, we have 180 Newton sine 350. We have minus 127.3. So by the time you add all the values here with their respective sign, the one that is negative, take it as negative. The one that is positive, take it as positive. Combine them to get your algebraic sum. The algebraic sum of all the values here would have given us minus 21.6 Newton. So this is the resolving forces in X direction. This is the one in Y direction, which is the same thing as what we have here. So whichever method you use, you have the same result. Remember, after you have gotten this table, then you now continue from your sketch till where you get your answer. Right? So we don't need to continue again. I just want to show you how to resolve these forces along X and along Y using tabular method, which we have already shown. So from here, you continue from this diagram, calculate your resultant, calculate the angle the resultant made with S axis, then you can now calculate the direction of the resultant as usual. Hope you have gained another massive value for this class. Guys, is this not wonderful? I have just held you by the hand and walked you through the process of solving concurrent forces or obtaining resultant and its direction from concurrent forces acting at a point on force system where you have four forces in different quadrants acting at a point. So any other problem you will have will equally be solved in a similar manner. And I just used two different methods to show you how to resolve these concurrent forces with respect to X axis and with respect to Y axis. Now guys, will you be selfish with this platform? Will you be selfish with this content? Guys, help us share this video to your friends. Let it go viral. Like this video, share this video, make your necessary positive comment. Now, if at this point you still have some things you don't understand, guys, rewatch the video again. And if you have a question to ask, don't hesitate. Slide down to the comment section and make your questions known to us. We are good at answering questions. Very shortly, you can check the description below where you will find the link to the next lesson, which is problem number 11. See you guys in that class.